Welcome to this video on distributions of the sample mean, more examples. This video picks up where the last video on distributions of the sample mean left off. After watching this video, you will be able to calculate the mean and standard deviation of a sampling distribution given the population mean, population standard deviation, and sample size. You will also be able to answer questions regarding the probability of an event by constructing a sampling distribution and using the normal calculator in Statcrunch using both standard and between settings. If you have not already done so, please watch my first video entitled Distributions of the Sample Mean before watching this video. Example 6. We're starting on example 6 because examples 1 through 5 were covered in the previous video. Suppose a simple random sample of size n equals 81 is obtained from a population with a mean of 50 and a standard deviation of 9. What is the shape of the sampling distribution of x bar? Here's the central limit theorem. Notice that we have a sample size of 81. That means that our sample size is larger than 30. Therefore, it doesn't matter whether or not we even know how the population is distributed, and it doesn't matter whether or not it's normally distributed because our sampling distribution will be normally distributed, again, because our sample size is larger than 30. So we can say that the sampling distribution is approximately normal because n is greater than or equal to 30. Now let's find the mean and standard deviation of the sampling distribution. Since our sample size is larger than 30, we can assume that the sampling distribution will be approximately normal, with our sampling distribution mean being the same as our population mean, and our sampling distribution standard deviation being equal to our population standard deviation divided by the square root of the sample size. So the mean of our sampling distribution is 50, and the standard deviation is 9, which is our population standard deviation, divided by the square root of n. So 9 divided by the square root of 81 gives us 1. Therefore, the mean of the sampling distribution is 50, and the standard deviation of the sampling distribution is 1. So now that we know the mean and standard deviation of the sampling distribution, and using the central limit theorem, we know that it's approximately normally distributed, we can create a model of our sampling distribution. Notice that the mean, the sampling distribution mean goes in the middle, which is 50, and then as we go to the right, we are adding standard deviations, which is 1, and as we go to the left, we are subtracting standard deviations. So we can use this model to answer questions about the probability of the sampling mean being less than, greater than, or in between two values. So we want to find out what is the probability of our sample mean being less than or equal to 48.2. What's the probability that it's greater than or equal to 51.32? And what's the probability that it's sandwiched in between 49.5 and 51? And we're going to be rounding all of our answers to 4 decimal places. So let's start with the first problem. What is the probability that our sample mean is less than or equal to 48.2? And again, we're rounding to 4 decimal places. So the first thing that we have to do for this problem is go into Statcrunch. So as you can see here, I'm at the Statcrunch website. I've already logged on, so now I can click on Open Statcrunch. So I'm using the normal calculator, so I'm going to hover over Stat, Calculators, and Normal. So this is the app that I want to use. So remember, we figured out in the previous slide that our average or our mean is 50, our standard deviation is 1, and then we're curious what proportion or what percent of the population would be less than or equal to 48.2. So if I hit compute here, you can see that the answer is about 3.6%. So coming back to our PowerPoint slide, here is our picture. And again, the probability of finding a value that is equal to or less than 48.2, in other words, this red shaded area under the curve, is about 3.59%. Let's do another problem. So we're still working in the same example. However, this time we want to find the probability that our sample mean is greater than or equal to 51.32. Again, using the population mean of 50 and our standard deviation of 1. So again, let's go to Statcrunch and figure that out. So now we're back in Statcrunch. The mean and standard deviation are not going to change. What is going to change is our greater than or equal to sign and this value right here. So we hit compute, and it looks like that the area to the right of this line is about 9%. So this is the third part of our problem. Again, we're still using the same mean and standard deviation. Now we want to know what is the probability of finding a sample mean that lies between 49.5 and 51. So once again, we have to go to Statcrunch to find that answer. In Statcrunch, you can see here, the problem is that I'm only given the opportunity to pick a single inequality sign and type in a single number. So you might recall, we have to click on this between button up here, and then we can type in our values. So the values we want to type in are 49.5 and 51. And then we hit compute, and we get our area right there. So here is our picture. And if we were to write a summary sentence, that would just say the probability of the sample mean being between 49.5 and 51 is about 0.5328 or 53.28%. Here's another example. Suppose a simple random sample of size n equals 12 is obtained from a population with a mean of 52 and a standard deviation of 10. What must be true regarding the distribution of the population in order to use the normal model to compute probabilities for the sample mean? Let's first bring up the central limit theorem. Remember, if we have a sample size that is larger than or equal to 30, then the distribution of our population does not matter. But what sample size are we given here? We're given a sample size of n equals 12. Therefore, this rule here is not applicable. So the only way that I can obtain a sampling distribution that is normally distributed is if I start out with a population which itself is normally distributed. So in order to use the normal model on my sampling distribution, the population must be normally distributed. Otherwise, there's nothing I can do with this problem. Suppose a simple random sample of size n equals 12 is obtained from a population with mean 52 and standard deviation 10. Now we're going to go ahead and assume that the population is normally distributed so that we can apply this model. What is the shape of the sampling distribution? Again, using this guide here, we can see that since the population itself is normally distributed, we can assume that the sampling distribution will also be normally distributed. Again, even though our sample size is less than 30, it's okay because our population is normally distributed. So let's find the mean and standard deviation of the sampling distribution. Since the population is normally distributed, again, we can assume that the sampling distribution is approximately normally distributed. So the sampling distribution mean is the same as the population mean, but remember for the standard deviation, we have to divide again by the square root of n. So what is the standard deviation? Well, it's going to be 10 divided by the square root of n, which is 12. So 10 divided by the square root of 12 is approximately 2.8868. And you can see here I had to round the last digit. Therefore, the mean of the sampling distribution is 52, and the standard deviation is 2.8868. Now that I have this information, I can answer questions about the probability of the sampling distribution. Note that if you fail to include enough decimal places in the standard deviation when you type it into Statcrunch, you might end up with some rounding error in your final answer. So let's use the values we obtained to find the probability that our sampling distribution mean would be less than or equal to 50. Remember that in our previous slide, we found a sampling distribution mean of 52 and a standard deviation of 2.8868. So we're going to navigate over to Statcrunch and figure out what this probability is. So in Statcrunch, I'm going to type in 52. And for the standard deviation, I'm going to type in 2.8868. Remember, you want to give at least 4 digits after the decimal point here so that you don't end up with some rounding error later. So we want to find the probability that our x bar here is less than or equal to 50. So notice when I'm looking at this graph, it goes from 45 to 50, 55, 60, which is great if you're in an algebra class. But remember, for statistics, we really want the mean to be in the middle. And the way we do that is to click on this 68, 95, 99.7 ticks box. That puts our mean in the middle, and it makes each tick mark to the left or right one standard deviation away as we move. So in other words, 52 subtract one standard deviation gives you 49.1, and so on and so forth. So back in our PowerPoint, you can see that I've pasted this graph here. And again, the probability that our sampling distribution mean, our sample mean, would be less than or equal to 50 is about 24.42%. So now we're going to find the probability that our sample mean is greater than or equal to 53. So coming back to Statcrunch, the two things we need to change are the inequality sign. So now we have greater than or equal to, and I need to change this value to 53. And then I hit compute, and that gives me the probability. So as you can see, here's my graph. And so the probability of a sample mean greater than or equal to 53 is about 36.45%. Let's do one more example. This example is about herpetologists, which are snake experts. They found that the length of a certain species of reticulated python are normally distributed with an average length of 20.5 feet and a standard deviation of 2.3 feet. One herpetologist fears that pollution might be affecting the natural growth of pythons. So the first thing we want to find is what is the probability that the length of a randomly selected python is 19.5 feet or less. So let's stop for a minute and ask ourselves, is this just a normal distribution problem, or is this a sampling distribution problem? Then they want to know, what is the probability that the average length of a random sample of 30 adult pythons is 19 feet or less? Is this a normal distribution, or is this sampling distribution? Pause this video and think about it. Write down your answer and then unpause it to see if you are correct. So notice that the first bullet point is a normal distribution because n is 1. We're only looking at the probability that a single snake is this size. However, in the second bullet point, you can see that we're given an n of 30. We're looking at the average size of 30 pythons. So since n is greater than 1, we have to find the sampling error of the mean, meaning that we have to change our standard deviation by dividing by the square root of n. Let's begin with the first bullet point. What is the probability that the length of a randomly selected python is 19.5 feet or less? So now we're in Statcrunch. Once again, we're in the normal calculator. So our mean is 20.5. Our standard deviation is 2.3. And we want to find out the probability that a single python has a length of less than or equal to 19.5 feet. So I can hit compute, and that gives me my probability. Remember, anytime you want to capture this image, you really want to click on this tick mark so that your mean is in the middle, and each tick mark represents the difference of one standard deviation. So back in Statcrunch, you can see that I've pasted the image here from Statcrunch. And so the probability that a single python has a length of 19.5 feet or less is about 33%. Now let's tackle the second part of this problem. It says, what is the probability that the average length of 30 snakes is 19.5 feet or less? So we need to find the mean and standard deviation of the sampling distribution. So we know that the mean is the same as the mean of the population, which is 20.5. So that will not change. What will change is the standard deviation. Remember, we have to divide by the square root of 30. So that's going to give us a new standard deviation of about 0.4199. So now that we are equipped with this new information, we can use Statcrunch to calculate this probability. So let's look at our normal calculator. Our mean, 20.5, is not going to change. But what is going to change is our standard deviation. It is now 0.4199. Nothing else changes. We still want to find the probability that our, in this case, sample mean is less than or equal to 19.5. So now that we're back in our PowerPoint, we can see that this probability is quite small. The probability is about 0.86%, which is less than 1%.